Good afternoon, everyone. We'll continue with the last class numerical, which we had left it uh, half done. Okay, we were dealing with drawing the or getting the values of shear force, bending moment diagram, absolute bending moment diagram for a type of numerical where there are a series of point loads, right? So I'll just draw the diagram once. It was this. I think my Zoom board is zoomed too much. So the beam was like this, and the beam was 30 meters in length, right? And over this, there were four loads moving together, 4 point loads that were spaced at 2 meters each, right, in between. And the loadings were 100 kilonewton, 120 kilonewton, 80 kilonewton, and 50 kilonewton. Correct. So these were the series of load that were moving over this girder or the beam. And for this, we had to find various parameters such as reactions, right? So when we were finding the reactions, when I wanted to find this was A and this is B, right? So when I wanted to find RA, what we did was we kept all the four forces starting from point A, right? This was your A, this is your point B. The four forces or the loads, right, from 100 to 150 kilonewton were placed such that the last load is placed at point A, and this is the pattern. Okay, remaining distance is automatically 24. Based on this, we drew the ILD for unit load. We know in case of a point load what is ILD, and based on this, we found their ordinates and then calculated the total reaction RA. So when we had to do it for reaction at B, we placed the loads in this pattern, right? The four loads in this pattern, and we know the ILD for reaction at B, right? And then got the ordinates, and then we calculated RB. Here we calculated RA, correct? So here RA may all four were from last load was on point A, and in RB when I was calculating the first load was on point B, correct? So we found the RA and RB. Once this was done, then we had to calculate the maximum negative shear force and maximum positive shear force. So when we were dealing with shear force, how you got them? Anybody can tell me? Do you remember how we calculated the negative shear force? This was our beam B, A. Okay. They had told us, they had given us a point C which was 10 meters away from A. And they asked us to calculate the shear force at this point C, negative and positive both. So in that case, first I for to get the negative shear force, I placed the first load that is 100 kilonewton at point C, and then they got uh, placed. Others were according because they have 2 meters spacing between them. They were placed like this. This was four, and this was the pattern how the loadings four loads were placed on the beam, and based on our negative shear force diagram, right, we are aware of the negative shear force diagram. It goes like this, correct? So top one is positive, so we'll not draw that. So only bottom negative shear force, we know this is going to be 1, and based on that we calculate these ordinates, and then once we got the ordinates we calculated the negative shear force value at point C, that is load into the ordinate was giving us the value of the shear force, right? Similarly, when we were calculating for the maximum positive shear force, this was A, this was B, this is the point C, correct? We placed the load such that the last load was on this, and from here at equidistance were the four loads. So you can also remember this as uh, when the system of four loads start entering, right? When they start entering this, that time we'll have a negative shear force. And when they cross the point, that is the point given, we will have a positive shear force. So this is 100 and this last one is 150. So based on this, we got the diagram for positive shear force. We know this is the diagram, right? ILD. And then we found the ordinates, respective ordinates, and we calculated the positive shear force value for this. Correct? So for negative, place the first load on the point C. For the positive, place the last load on the point C, and they'll give you the equidistant values. So based on that, you place everyone, all the other four loads, and write their distances. And then from this, calculate the ordinates. Ordinates into the loads will give you the value of the shear force. Then we were dealing with the maximum uh, bending moment, right? So when we were calculating the bending moment, we put up a table wherein it was serial number, then load crossing, right? The load that was crossing, then average load in AC and average load in CB, right? And then remarks column. We put up a table like this, and we placed or how we passed was one by one the load were crossing the point C. So first time we put the load 100 kilonewton over here. First load is 100 kilonewton. So the load that crossed the section C was 100 kilonewton. So average portion in AC were remaining three loads. Three loads were remaining in this junction. So we'll take the average of those. How you calculated average? The loads divided by the length AC. We calculated the average. Then average load in CB was the load that has crossed, that is 100, divided by CB we did, and we wrote here AC is greater or AC is less than value was written. Okay. Then after this, just give me a moment. Okay, just give me a moment. I'm getting a hello. I'm so sorry. I'm back. I just connect the phone back. The board is visible. Yeah. Okay. You all are there. Hello.
Yes,
Yes,
ma'am.
ma'am.
I'm so sorry. Okay. Urgent call. I couldn't leave it, but I've diverted. Next, then we were dealing with here. Uh, AC one crossed, then second section C will second load passes, that is 100, along with one more load, that is the second load was I think 120. So similarly you will draw for all the four, right? Cross each set of loads point C, which is a given point, and then you calculate the averages. Once you calculate the average, there comes a point where your AC becomes equal to BC, and that we got I think for our third load, which was 180. No, which load it was? 120 kilonewton. No? Anybody has written notes? Yeah. 80 kilonewton ke liye we got a section which is AC equal to BC, which indicated that our beam like this, and this is the point C. So 1, 2, 3, and 1, something like this, right? So we put up this table to calculate the maximum bending moment, and then based on that, we drew the ILD for a bending moment diagram, right? With highest ordinate AB by L. A value would be AC and B value would be CP divided by L. AC is given to us 10 meters. CP would be 20 divided by L, and then calculate the ordinates of the others and then load into the ordinate. Okay. We calculated that was the maximum bending moment that we have got. I think we have done only till here. Am I right? So we got a maximum bending moment whose value was 2584 something kilonewton meter. So next we were doing absolute bending moment, right? We had started this. So absolute maximum bending moment, right? So we were doing this. Here, our first step we did was to find the resultant. So the resultant means what? We have four loads, one, two, three, four, and we simply add those loads. That is 150 plus 80 plus 120 plus 100. We got 450 kilonewton. That was the resultant load. This was our first step. In this, we have to find the position of this resultant. So I told you we apply the Varignon's theorem, if you remember. And Varignon's theorem states that the load into moments of the forces into the distances at a particular point will be equal to the moment of the resultant about the same point. This was the statement, or this is the statement of the Varignon's theorem. So the loads are like this: 150, 80, 120, and 100 kilonewtons are your loads. Resultant we had depicted somewhere around here. We don't know where it is. You can show it here also. Okay. Say I will not show it here. First, I will show resultant here. My choice. I don't know where it is acting. No. So this distance I will call it as R, and this is what we have to find. And between these two, between the loads, we know there are 2 meters. When I take moment, say this is A, or take some number, say this is P. Take moments at P. Okay, and I'm taking moment at P, 150 into 0, okay, and 80 into 2 plus 80 into 2 plus 120 into 4 plus 100 into 6. Correct? This is giving me 0 moment. 80 into 2, 120 into 4, 100 into 2 are the all the moments. Moment of all the forces will be equal to moment of the resultant. Resultant is also coming down R into X. I know the value of R, that is 450 into X. From here, we got the value of X. That is this entire thing divided by 450, you get the value of X. Can anyone remember what was the value of X if you have calculated there?
2.75.
Yes, 2.7758 ಅದು ಐತೇನದು? No problem. 2.75 would do. So you got a x value which is 2.75. When this is 2.75, I know that this distance is 2. 2.75 and it has crossed this. So I get the clue that the resultant is crossing this. It is between these two, 2 and 4 ke beech mein. This is resultant. And at x equal to 2.75 is our uh, resultant value or resultant acting. So once this is done, then we have to select the heaviest load nearer to the resultant. Now look at your resultant. Which is the heaviest load nearest to the resultant? Resultant is here. So the two loads which are nearing to the resultant are 80 kilonewton and 120 kilonewton. So we have to select the heaviest load nearer to the resultant, that is 120 kilonewton. So we will fix 120 kilonewton, and then that 120 kilonewton has to be placed in as shown. Okay. So the heaviest load is 120 kilonewton. Therefore, the position of loads is as follows, right? So I'll show you how it has to be done. This is your A, this is your B. Okay. Whenever we are drawing absolute, it is not visible. This is A, this is B. Whenever we are drawing for absolute, I know that I'll have to have a center point. Okay. So this is going to be 15 meters and this is going to be 15 meters. Correct? 15 and 15. Right? Now, we have four loads to be placed, and order is like this. Resultant is somewhere acting between second and the third load. This distance between this was how much? I'll show it here. This is first load was how much? 150. Then we have 80. Then we have 120. And then we have 100. Between each of them is 2 meters. Correct? And resultant was somewhere here. That is 2.76. Matlab, this is how much? 0.75. What is remaining distance here? 2 minus 0.75 is 1.25. Correct? So what you will do is you have to coincide this line of resultant. Okay, not coincide. You have to put this line of resultant towards the left of this point, center point. Or I can say that 120 is your highest load. So 120 to resultant, whatever is the distance, that center should coincide with this center. So if I tell that, if I'll tell you once again, I'll repeat. The highest load is 120, 120 and this is resultant. Correct? So 120 and resultant, the center point जो रहता है, that has to coincide with the center of the beam. Okay? So accordingly, if I do, center of 1.25 means what? 1.25 divided by 2 is how much? How much is 1?
0.25.
Huh? 625.
0.625.
625. Correct? Correct. So from here 0.625 point here, this is 0.625, this is 0.625, right? That means from your center 0.625 here, 0.625 here is your 2 meters, right? And this is 120. This is just 0.625. From here at zero point 0.7, matlab now this total is 2 meters. Is your next load, that is 80. Then your third load, that is 150. Okay, and here 2 meters pe you have 100 kilonewton. So the distances when I write, this is 0.75, this is 0.625, and this is 0.625. Is it clear? I mean, it's I'm not. You won't be able to write the see the writing, but the center of the maximum load and the resultant has to coincide with the center of this. Okay. Now, based on this, find the other length. What other length? This is 2 meters. Fine. What would be remaining this distance? This is 2. This is 0.75. This is 0.625. So 15 minus 0.625 minus 0.75 minus 2 would be the remaining. How much is that? Give me this distance. This total is 15. Usme remove 0.625, remove 0.75, remove 2. That would be the remaining distance. How much is this?
11.6.
11.6. Correct. Right. This side now. This is 15. This is 2 meters. Right. So this is 15. 15 minus 0.625 minus 2. How much is the remaining?
12.375.
12.35. 375. Yes. This is the loading system for absolute. Only thing you should keep in mind is you get the resultant. You follow the steps. You find the resultant. Then you find the x. That is applying Varigman's theorem. Find the x. Once you find that x, now this is resultant. This is somewhere our resultant is acting actually, right? So center of the beam, okay, you will place the distance between the resultant and the heaviest load. Center of that will be on the center of the beam. Like that, you have to do the placing. So once this is placed now, if I'm drawing the IID for maximum bending moment, right? So when I'm drawing the IID for maximum bending moment, I'll have to calculate A and B, right? So which point I will take as A and which point I mean AB by L we substitute, right? So can you tell me what is A and what is B? Where your resultant is acting? No, we will not take center. We will not take this is center line. Sorry, this is the center of the beam. I will not take center of the beam. Wherever is my resultant acting, that this distance becomes A, and this distance becomes B. Okay, so resultant is acting here 0.276, sorry, 0.75 ko resultant. So what is the value of A now? A would be 11.6 plus 2 plus 0.75. That is 11, 12, 13.6 plus 0.75 कितना हुआ?
14.35.
14.35. And B would be 30 minus 14.35 you do. No need to calculate from here. 30 minus 14.35 is B.
15.65.
15.65.
15.65 meters. So AB by L, say what I draw, the triangle like this. This is my AB by L, which is 14.35 into 15.65 divided by 30 ordinate. How much is the value?
7.48.
Correct. 7.48. This is 7.48. Now we have to get these ordinates. And we know the distances, right? I don't need this ordinate as in while calculating, but other ordinates are required. Now what we'll do, this is 7.48 known. I require these two and these two ordinates. Distance is C. This is 11.6. This is 2 meters. Okay. And here is going to be 0.75. This side till the load is 1.25. This is 2 meters and this is 12.375. Am I right? These two are the main loads, right? So इन दोनों के बीच में it is 2 meters, so 0.75 and 1.25 का distance. This is 2, this is 11.6. Okay. Now from here, let us call these as Z1, Z2, Z3, and Z4. I have to find the ordinates. So Z1 by 11.6 is equal to known factor I want. No, so I'll take this. So Z1 by 11.6 will be equal to 7.48, that is AB by L, divided by this distance, that is your A distance, 14.35. Okay, so Z1 divided by 11.6, Z1 by 11.6 is equal to 7.48 divided by your A value, that is 14.35. So you get the value of Z1 here. Similarly, I'll write for others also, Z2 divided by this distance. So Z2 divided by, it's not visible, Z2 divided by this 11.6 plus 2, 12, 13.6. So 13.6 is equal to 7.48 divided by 14.35. This is Z2. Okay. Then come this side. Z3 divided by this will be equal to this divided by B. So Z3 divided by this distance. 12.375 plus 2 makes it 14.375. 14.375 will be equal to 7.48 biggest ordinate divided by B distance, that is 15.65. It's not visible. You get Z3, and similarly we'll find Z4, that is Z4 divided by 12.375 will be equal to 7.48 divided by the B distance, that is 15.65. So Z4 divided by 12.375 will be equal to 7.48 divided by 15.65. Z4. Give me these values, please. Starting from Z1.
6.04.
6.04. Z2.
7.08.
7.08.
08. Okay, 7.08. Z3.
6.87.
Okay, and Z4.
5.91.
0.91.
5.91. Okay. So these are our ordinates, and now this ordinate into the load will give me the absolute bending moment. So I'm calculating the absolute bending moment, ABM, right? Okay. Absolute bending moment. Load into the ordinates. Load for Z1 is what? First load, 150. It's not visible. 150 into Z1, 80 into Z2, 120 into Z3, and 100 into Z4. Correct? So 150 into 6.04 plus 80 into 7.08 plus 120 into 6.87 plus 100 into 5.91. How much?
2887.8.
887.8 kilonewton meter. This is the absolute bending moment. Absolute bending moment at C. Okay, absolute bending moment at C. Here, so here only challenging task is, it is not challenging also. High school mathematics only, not even high school mathematics. Addition, subtraction, you should know very well. Placing the four loads with the center of the resultant and the maximum load, heaviest load ka center, you will place it on the center of the beam. That's it. Then you should have that idea that A and B are totally different. And then you will draw this ILD diagram and calculate AB by L. And then based on this, you will calculate the other ordinates. And then once you place this, finding the distances, you know, the diagram has to be very neat and you will get the values. Clear? So this is for absolute bending moment at C. We'll quickly take one more numerical so that it will just become easier for you to remember also, right? So the next numerical, 30 meter only there, this is also, but loadings are different. Okay. So the 4 point loads, it is point loads are 8, 15, 15 and 10 newtons, kilonewtons. Okay. Have a center to center spacing of 2 meters only, and there is a girder that is a beam of 30 meters. This is A and this is B, and this is 30 meters length. They have to be placed. They are traversing over the girder of 30 meter span, and then the highest or the first load being 10, which is entering, the last load is 8 kilonewton. We have to find the reactions, bending moment, shear force, if everything. Yeah. So when I want to find the reaction, quickly, all of you along with me, when I want to find RA, how do I place it? This is B, this is A. The 8 kilonewton will be here. Okay. This is 15, this is 15, and this is 10. Right? So this 2, 2, 2. Remaining is going to be 30 minus 6, that is 24. This is the ILD for RA. Right? So get the ordinates. This is 2, 2, 2, 24. This is 1. Correct? So this is Z1, Z2, and Z3. So how do we get the ordinates? 1 divided by 30 will be equal to Z1 divided by this distance, that is 24 plus 4, that is 28. Then 1 divided by 30 will be equal to Z2 divided by 26. 1 divided by 30 will be equal to, 1 divided by 30 will be equal to Z3 divided by 24. Am I right? From here, get me the value of Z1. Z1 is going to be 28 by 30.
0.93.
0.93. Okay. What is Z2? 26 divided
0.866.
866.
866.
0.866. And what about Z3?
0.8.
0.8. Yeah, last time also we got the same values. Right? Now I want to find the reaction at A. It is going to be 8 kilonewton into 1. That is the first one, ordinate. Plus 15 kilonewton into Z1. Okay. Plus 15 kilonewton. Third load also is 15. 15 kilonewton into Z2 is 2. 0.8. I'll write Z1, Z2 values here only. This is 0.93. This is 0.866. And lastly, 10 kilonewton into 0.8. Get me the value of RA, please.
42.94.
42.9 kilonewton. Anybody else? Are you getting the same answer?
Yes, ma'am.
Okay. So this is the RA, that is reaction at A. When we are doing reaction at B, this is B, this is A, we place the loadings like this now. And this is the influence line diagram. I need these ordinates. Correct? So this is 10, 15, 15, and 8. 1. I'll call this as Z1, Z2, Z3. So okay, this is 24, and this is 2, 2, 2. Right? So let us calculate Z1, Z2, Z3. 1 divided by 30 is going to be equal to Z1 divided by 28. Then 1 divided by 30 is going to be equal to Z2 divided by 26. 1 divided by 30 is equal to Z3 divided by 24. I think they're same values, no?
Yes, ma'am.
You get the same ordinates. 28 by 30 is 0.93, and this is going to be 0.866, and this is going to be 0.8. And the value of the reaction also is going to be same now, RB. So RB, when we are calculating, no, values will change. 1 into 10 plus 15 into Z1, that is 0.93, plus 15 into Z2, that is 0.866, plus 8 into Z3, that is 0.8. How much? RB?
43.34.
43.34.
Kilonewtons. So this is the reaction at B. Reaction at A and reaction at B. Correct? Then let us calculate the shear force, negative shear force and positive shear force. So first, when we were discussing, they have told find the shear force at point C, which is at 8 meters. Okay, it is at 8 meters from point A. So how do I place when we were calculating the shear force, the negative shear force, especially I want to calculate negative shear force. So when we are placing for the negative shear force, this is B, this is A, this is your point C. Okay, so the first load will be on C, that is this 10, then I have 15, then I have 15, then I have 8. So this is total is 8 meters. So remaining is how much? 30 minus 8 is going to be 22. Okay, this is 2, 2, 2. What is remaining? Remaining distance also is 2. This is the placement for negative shear force, right? AC in the portion AC, when I place the forces, when it just enters, it is going to be negative. Negative means how? Our diagram is going to go down like this, right? So now based on this, I need to calculate these ordinates. 1, 2, 3, 4, right? This side is 1. This distance is 22. 2, 2, 2, and remaining also is 2 by default. I'll call this as Z1, this as Z1. This is Z2, this is Z3, and this is Z4. Okay, let us calculate the ordinates. So 1 divided by 30, I get it here, 1 divided by 30 is going to be equal to Z1 divided by this distance, that is 8. Z1 by 8. Then 1 divided by 30, 1 divided by 30 is Z2 divided by 6. Then 1 divided by 30 is going to be equal to Z3 divided by how much? 4. Correct? And 1 divided by 30, 1 divided by 30 is Z4 divided by 2. Get me the values of Z1, Z2, Z3, Z4.
0.266.
0.266, Z2,
0.2.
0.2.
0.2, okay. Z3,
0.13. 0.133.
33.
133, okay. Z4, that is 2 divided by 30.
0.06.
0.06. Once you get the ordinates, therefore, maximum negative shear force at C, because 8 meters per we are calculating, no? This ordinate into the load with negative sign. Okay, so that means 10 into Z1, 15 into Z2, 15 into Z3, 8 into Z4, like that. So minus 10 into Z1, I will substitute here, okay, 266. Is it visible? Okay, then minus 15 into Z2, that is 0.133, minus 15 into Z3, that is 0.2, minus 8 into Z4, that is 0.06. Get me the value, please. All are negative signs. So you can all add and then put a negative sign at the end.
minus 8.135.
Minus how much?
8.135.
5 kilonewtons. Okay, fine. This is the maximum negative shear force. Then same way, when I'm calculating the positive shear force, so this is your B, this is your A, this is the point C. The last load will be on C, and then the loadings go like this. Right? So what are our loadings? 10, 15, 15, 8. 8 ala? And then 2, 2, 2. So 22 minus 6 is how much? This is 8. 22 minus 6, yes to?
16.
60. Right? Positive shear force, matlab the diagram triangle is going to be like this. And I need to calculate these ordinates starting from Z1, Z2, Z3, and Z4. This is 8, this is 2, 2, 2, and this is 16. Correct? This side is 1. Again, let us calculate the ordinates first. 1 divided by 30 is going to be equal to Z1 divided by 16 plus 8 is 22. Correct? Then again, 1 divided by 30 is equal to Z2 divided by this. 16 plus 4 is 20. 1 divided by 30 is equal to Z3 divided by this. Z3 divided by this is 18. And 1 divided by 30 is equal to Z4 divided by 16. So get me the values of Z1, Z2, Z3, and Z4.
0.733.
0.733. Okay. Z2,
0.66.
0.66. Z3,
0.6.
0.6, and Z4,
0.53.
0.53. So maximum positive shear force at point C when we are calculating 10 into Z, sorry, it's from here, 8 into Z1 plus 15 into Z2 plus 15 into Z3 plus 10 into Z4. Load into the ordinate. So I'll start with here 8 into Z1, that is 0.733, plus 15 into Z2, that is 0.66, plus 15 into Z3, that is 0.6, plus 10 into Z4, that is 0.53. Get me this.
30.04.
30.04. Correct. Kilonewtons. Okay. Any doubt? These are the shear forces that are coming, maximum positive shear force based on this, right? So remember how to place the loading and calculating the ordinate. That itself is the important task. Once that is done, everything else is simple only. Okay. Then once this is done, next what we have to do? Maximum bending moment. We will calculate the bending moment. So table comes, serial number, then load that crosses C, section C, and average load in AC, average load in CB, okay, and your remarks, right? So first, we have 4 loads, where I'll show them, I'll show here. 1, 2, 3, 4. And what are their numbers? 10, 15, 15, and 8. Okay, these are our 4 loads. Now, first one, 10 crosses. Okay, so average load in AC is going to be 8 plus 15 plus 15 divided by the length of AC is 8. How much?
4.75.
4.75. I hope you understood this. What I did, only the one crosses the point C on the beam. Remaining 3 are 15, 15, 8 in a span of AC. AC is 8. Okay. At CB, it is going to be 10 divided by 22. How much is this?
0.45.
0.45. So your AC is greater than CB. Remark. Correct, no? AC is greater than CB. Next, second time, second load, 15 passes. So when 15 goes there, 15 also goes. So your remainder would be 8 plus 15 divided by 8. Okay. And on CB section, it is going to be 15 plus 10 divided by 22. How much are these values?
2.87.
2.87. And here?
1.13.
1.13. Here also AC is greater than CB only. Still, correct? Then third one, third load, 15. Again, another 15 passes. So when another 15 passes, I'm left up with in AC only 8. 8 divided by 8. That is going to be 1. Correct? And this side it is going to be 15 plus 10 divided by 22. How much?
1.81.
1.81. Now CB has increased, then AC. Last one, if I do also, that is the last one, 8 also crosses. Here it will be nil. Here it would be total load, right? So if you don't write that also is fine. Okay, you can leave it at this point. So I know that at this point, when the 15 is crossing, CB is greater than AC. That is the third load. So when we are drawing now for maximum bending moment, your triangle goes like this. Or I'll draw the beam first, right? This is our beam A, B. This is the point C, which is at 8 meters. Correct. When the third load passed, that is 15th load passed, that time this became CB became more. Correct. So I will place that third load at this junction. The other two are here, and the last one is at this junction. So what are these values? 10, 15, 15, 8. Right. And based on this, when we draw the triangle, keeping C as the point. This is AB by L. The 8 and this is 22. So 8 into 22 divided by 30. Kitna?
5.86.
5.86. This is the ordinate of at point C. Right? At now this side there is one line and this side there are two more lines. I need to find these ordinates. I'll call them Z1, Z2 and Z3. Right? Distances let us find. This total is 8. This total is 22. Correct? In this is 2 meters, so remaining would be 6 meters. Here this is 2, 2. So 22 minus 2 is 20, minus 2 is 18. Correct? Let us find the ordinates now. What is this? 5.86 divided by 8. Okay, 5.86 divided by 8 is equal to Z1 divided by 6. Okay, come to this side of the triangle. 5.86 divided by 22 will be equal to Z2 divided by 20. Third equation, 5.86 divided by 22 is equal to Z3 divided by 18. From here, get me the value of Z1, Z2 and Z3, please.
4.39.
4.39. Okay.
5.32.
5.32. Okay, great.
4.79.
4.79. I hope you understood why we put this table. From this table, I'm getting which load pay that portion we are trying to balance AC and CB. So at the third load, that portion is nearly equal to or it crosses. So that third load is placed on that point C. Okay. Previously also it was same. So we got the Z1, Z2, Z3 values. Now to get the maximum bending moment at point C, what we have to do? Load 8 into Z1, 15 into 5.86, 15 into Z2 and 10 into Z3. Right? I will write the equation here. 8 into Z1, that is 4.39 plus 15 into this ordinate is calculated AB by L, that is 5.86. Okay, plus another load is 15 into the third ordinate Z2, sorry, Z2, that is 5.32, and last is 10 into the fourth ordinate Z3, that is 4.79. Get me the bending moment, please.
250.72.
Correct. Okay. This problem is from Navigated textbook. He's got a different methodology. This is a little different methodology, but answers are same. He's got 251. We are getting 250. It's okay. That much is acceptable because fractions that this goes. So 250.72. Correct. Absolutely right. Understood how to get the bending moment from these loads. Now, shall we do for absolute? Let's see for what happens with absolute. For absolute bending moment, what is the first step I have to do? I have to find their resultant, right? So absolute bending moment we will calculate. Okay. So first step is resultant. So how I get the resultant? I'll add all of them. That is the resultant. That is 8 plus 15 plus 15 plus 10. How much? 30, 40, 48. Correct, no?
Yes, ma'am.
Then second step, I have to find the distance where it is. So this is your beam. 10, 15, 15, and 8. Something like this is 2, 2, 2. Where resultant is acting, we do not know. We'll say that the resultant is acting here at a distance of x. Let us call this point as O. Let us take the moment at O. When I'm taking moment, take moment at O. When I'm taking it moment at O, it is 8 into 0 plus 15 into 2 plus 15 into 2, 15 into 4 plus 10 into 6 will be equal to resultant 48 into x, 48 into x, right? From here get the value of x. It is going to be 15 into 2 plus 15 into 4 plus 10 into 6 divided by 48. How much is the value of x?
3.12.
3.12 meters. So this is 2. It has crossed 2 here somewhere. 3.12. Your resultant will be acting here now of these four forces at 3.12. So let us place the loads then. Okay. 3.12 you remember. Now comes the challenging is how to place positioning. So select the heaviest load. Heaviest load means both are 15 only. It is exactly in between of 15. Right. So your loads are what? 15, 15, 10 and 8. And resultant is here. That is at, what is the distance? X distance? 3.12.
Yes, ma'am.
So 3.12 is the distance. So both heaviest loads are 15 only. Nearest heavier load. How I'll calculate? So idu 8, idu 15, idu 15. This is 10. Correct? This is 2. This is 4. 3 is here. 3.12 means here. It has crossed this side. So nearest 15 is the right side. Am I right? So this is 2, 3, 1.12. Ala? This distance is
Yes, ma'am.
1.12. So nearest 15 is the third load, right? Now based on this, we have to position it on the beam. I'll try to draw it neatly. I draw neatly, but sometimes it is not visible. I know. So this is your center point, first of all. That is 15 and 15 ka center point. So where I should place it according to absolute ka, whichever is the nearest load, uska distance pehle nikalo. So 2 minus 1.12 is how much? Remainder. 2 minus 1.12 remainder is how much?
0.88.
0.88. Then divided by 2 ಮಾಡಿದ್ರೆ 0.44 ಬರ್ತದಲ್ಲ. So half of that is 0.44. Correct? So I have to place That 0.44 should come here now. Half of this, center of this. So from here at 0.44, I have 15. And then from there at 0.44 is your resultant acting. And then from there at 1.12 is your loading acting. That is, this load is 15 now. Okay, this is the another 15. Here you have 8 and here you have 10. Now see the distances you see. Okay, this is 0.44. Okay, and here this is 1.12 and this is again 0.44. This is 2 and this is 2. Tell me this distance, please. I'll tell you how to calculate this distance. Do 15 minus 1.12 minus 2
11.44.
is to 11 point.
44.
Okay. What is remaining distance? 15 minus 2 minus 0.44.
12.56.
Okay. It's correct, 11.44 plus 2 plus 1.12 plus 0.44. Now calculate the A and B values, please. A value ಏನೈತಿ 11.44 plus 2 plus 1.12 plus 0.44. How much? What happened? I think you calculated this wrong, no? Hmm?
It's 15, ma'am.
A value would be here. And this would be B. Under the load, no? Under the heaviest load is A. So that is what? 15 plus, I think this becomes 15.44. From the diagram it is visible. Remaining would be 30 minus 15.44 is how much? E point, below this point is my A point, heaviest load. Previously also when we took AB, below the 120th point, 120 kilonewtons we took, right? A distance. That was 15.62 we had got. So now this point means I know this distance till here it is 15, this remaining distance is 0.44. So this is 15.44 is your A. What is B? 30 minus 15.44 is to
14.56.
14.56. This distance, this load is important, heaviest load. That is your AB point. And then I draw a triangle now. Your triangle is going to be like this. Under this load is AB by L. That is 15.44 into 14.56 divided by 30. How much?
7.49.
7.49.
7.49. Now ordinates of the other have to be found. They are equidistant at 2 meters. We are aware of that, right? This is 2, this is 2, and this is 2, right? Remaining is what? I hope this calculation is correct, yours. Or you know now this is 15.44, say minus 2 minus 2. What is this remaining distance? 15.44 minus 4. 11.44. And here do 14.56 minus 2. 12.56. Correct. Now this ordinate you know 7.49. Calculate the other ordinates. Call them at Z1, Z2 and Z3. Calculate the ordinates. So say 7.49 divided by this distance. This 2. A value. This is ours. 15.44 is equal to Z1 divided by 11.44. Z1 divided by 11.44. Similarly, 7.49 divided by A, that is 15.44, is equal to Z2 divided by this 11 plus 2, that is how much? 13.44. You get Z1, Z2 here. Similarly, third one, 7.49 divided by B distance, 14.56 is equal to Z3 divided by 12.56. Get the values of Z1, Z2, Z3.
5.549.
5.549. Okay. Z2 is
6.519.
okay. And Z3
6.46.
6.46. Now absolute bending moment would be how much? 8 into Z1, 15 into Z2, 15 into 7.49, and 10 into Z3. Okay. So absolute bending moment when I'm writing, it is 8 into 5.549, that is Z1. Okay. Plus 15 into Z2, that is 6.51, plus third load 15 into the ordinate which is found AB by L, 7.49, plus 10 into last one 6.46. What is the total?
318.99.
318.9 kilonewton meter. This is the absolute bending moment, correct also. See, at point C, which is 8 meters from A, we had got 250. So this is nearly at the center, which is increased. Okay, so this is the solution for the absolute bending moment. Absolute bending moment is not solved in the textbook. I will solve this and I'll send this to you individually on a sheet of paper. Okay, any doubts still here? We'll take up some more numericals tomorrow. Tomorrow we have a class. We'll take different numerical again tomorrow. If you have any doubts, you can ask me tomorrow again. Okay, we have a class tomorrow 3 to 4. No timings change. It will be 3 to 4 only. Okay, you can put your USNs in the chat box and you can leave the meeting.